Combat robots are super cool, but they can be pretty expensive to build, right? Well, I wanted to find out just how cheap I could make one, so I built this. This is Measured Response, a tiny combat robot which was designed using FreeCAD software on a crappy notebook, built with budget parts, and it misuses stationary equipment to dish out the damage. In this video, I'll walk you through how to build your own, how much it costs, and how to have fun in this hobby on a budget. Let's get started. How's it going, guys? Angus here from Maker's Muse. In a previous video, I explored using second-hand laptops to 3D model using Onshape. It worked okay, and this little robot design was the result. So what does a tiny combat robot like this actually need? Pretty much all combat robots include a variation of these components, so let's go through all of them one by one. With prices in AUD, we'll start with the transmitter. You need to be able to control your machine from outside the arena, and there are a ton on the market to choose from. I went with the Turnigy TG9 i4X because it was on clearance sale at the time. It cost next to nothing, but I've since found you can get a much better 6-channel FlySky i6X on AliExpress for about $50 plus shipping. It's really important you choose a transmitter which transmits using the same protocol as your receiver. So in this case, that is AFHDS2A, which is a fairly old protocol, but I've chosen it because it talks to the control board I've chosen for this build, a Malenki Nano. The Malenki Nano combines receiver and motor controllers in one compact board, which is really handy for tiny robots like this. It has 3 reversible brushed ESC channels, and each is current limited to 1.6 amps. This means you won't burn out the ESC if you jam up a drive motor during combat. There's also 2 PWM channels which you can use to control things like external weapon controllers or servo motors, and the only thing to watch out for with the standard Malenki Nano is that the max input voltage is 8.5 volts, which means you can only use up to a fully charged 2S LiPo, or you risk blowing up the board, so keep that in mind. For drive motors, 150 gram ant weights almost universally use N10 or N20 gear motors. These can be found at wildly different price points and quality. For this budget build, I grabbed a 10-pack of 6-volt 1000 RPM N20s from AliExpress, but I do not recommend these for reasons explained later in the video. Because I'm going with a basic horizontal spinner, a brushless outrunner of some kind is a good choice. I decided to go with this 2204 for $12, and I'll be honest, it's hard to know which motors will last in combat, and they're pretty much consumables at this weight class, but they're cheap, so I tend to just grab a few random ones at a time to have on hand and try out in various competitions. To control it, I reused a Little B Heli S brushless speed controller rated at 20 amps, which has been used in many of my previous combat robot builds. Tiny robots need a tiny battery, and these Llama Forge 195 mAh 2-cell packs are perfect for ant weights here in Australia. Highly recommended. Then there are the things people often forget about. You need a power switch and a status LED so people know the robot's on. You could technically get away with a removable link as a switch at this scale, but I really like the latest BotBits ant switches, which you can turn on and off with a tiny hex driver. For the status LED, I used this cheap super bright 3mm blue LED from the local J car and a suitable resistor, calculated using this equation. I get asked about this one pretty often, so here's what I do. For the equation, I'll plug in the fully charged battery voltage, the LED voltage drop, and I'll go and get the current from the datasheet, but I'll drop this down a bit because you don't need to run the LEDs at full brightness. They're super bright as is. For example, in this case, it's 20 milliamps. I'll drop it down to 15 milliamps, and I'll use the fully charged 2-cell battery voltage at 8.2 volts, and the LED has a voltage drop of 3.2 volts. With all of that put in, the calculation suggests a 333 ohm resistor, so the closest in my stash was a 330 ohm, and it works totally fine. And with that small detour, here is the full price breakdown. $116 dues. Now, I know what you might be thinking, what the stuff, Angus? That's not very cheap at all. Well, yeah, okay, it's certainly not in the range of a crappy remote-controlled toy, but consider this. There's only some components in this list that are within the robot and run the risk of being destroyed, and it's pretty uncommon for that to happen, especially to your ESC and battery. You You're going to lose drive motors, you're going to lose weapon motors, but really that's about it generally. And the other stuff like the transmitter, well, that's never going to get damaged, and you can use it again and again and again in all of your future builds. I really think the fact you can build a competitive little combat robot for less than the cost of 2 Switch games is pretty darn cool. So let's crack on with the build. This design is a fairly simple sandwich style construction with a TPU chassis and polycarbonate top and bottom plates. And yes, although you can print polycarbonate on some higher end printers, I find that polycarbonate sheet is way tougher in combat. So to create the top and bottom plates, I 3D printed out a template instead. I then traced it out onto some 3mm polycarbonate scraps I bought from a signage store for a few bucks, and from there I just had to mark, center punch, and carefully drill out the holes before cutting out the whole thing on a bandsaw, being very, very careful of my fingers because bandsaws, quite frankly, terrify me. The TPU chassis was printed on the Prusa Core 1 in Fibrology 40D, which is a new filament for me and admittedly not a budget brand or budget printer, but you could so easily print an equivalent part on the Bamboo Lab A1 Mini, for example, in a cheap 95A Shore Hardness TPU. And I'm just evaluating the Core 1 currently, so I decided to use it for this part with a supplied filament. I didn't even use any special settings, I just set it on defaults for flex, and it printed out beautifully, if a little bit slow. The key to this sandwich construction are these M2 standoffs. Once again, I bought them on clearance from Hobby King, but you can easily find equivalents on AliExpress and Amazon. I've given up trying to use threaded inserts in combat robots because they either pull out or they tear through the frame in big impacts. They just don't seat well in flexible plastics. Plus, the brass is actually pretty heavy at this scale. Don't get me wrong, they're fantastic for other applications. I use them all the time for my other projects. But yeah, when it comes to the TPU frames and big impacts, these standoffs have proven far more resilient. Next up is the fun part, wiring. It is critical to connect up everything correctly with good solder joints and plenty of wiggle room for the wires and parts. Otherwise, you'll end up blowing it all up and making a whole lot of expensive magic smoke. So please take your time, and if you're new to soldering, practice first before trying to solder the tiny wires to your expensive Malenki Nano. I'll probably do a video just on how to solder in future, so if you want to see something like that, let me know in the comments below. Before powering on, make sure you check all of your connections for shorts with a multimeter. It's a very quick and easy thing to do, and then it's time to power it up and do a quick test. If this is the first time, you'll need to bind the transmitter to the Malenki so they're paired. Just look in the instructions to figure out how to do that. And on mine, all looks good, except of course, one of the drive motors spins the wrong way. Thankfully, this is a very easy fix. You simply flip the wires on that side motor, and we are good to go. Now that the electronics are working, it's time to make up some wheels and that all-important weapon blade. Wheels can actually be pretty challenging for these little robots. I used to use these foam ones that worked really well, but they haven't been in production for like 10 years. So I decided to just try cutting some wheels out of some EVA foam with a very crap adjustable hole cutter. Unfortunately, it turns out that EVA foam doesn't really have any traction. So I did a little experiment with this traction spray I found at Bunnings, and that was a miserable failure. So don't bother with that. But still, it's just a spinner, so it doesn't really need much traction, and I can look at better alternatives for the version 2. For the weapon, it's true budget time with a metal ruler. Seriously, these stainless steel rulers are incredibly tough and they're super thin, which actually makes them really good at slicing through TPU frames if you get good bite. To make them, you just measure off the length required. It's easy to do, they're a ruler, and then you cut them off, and then you want to find the center point roughly to center punch and get a hole through. And I recommend using a cobalt drill bit to do this because again, they're quite a hard steel. But before drilling the bore out even further, I decided to give balancing it a go because, again, this is just roughly done by hand. So I grabbed a 2mm shaft from an old broken brushless motor and put it in the vise to identify the heavy side of the blade. I then used my old bench grinder to take away materials slowly but surely, checking and rechecking until I was happy that the blade was close to balanced. It doesn't look pretty, but it should spin pretty true. Once I was happy, I drilled the bore out to the final size in steps because you don't want to go from small to big, especially in a hard steel like this. and it's ready to bolt onto the weapon motor. But I hear you guys typing furiously in the comments, what if I don't have a bench grinder, angle grinder, or even a workshop environment at all? Well, thanks to this video's sponsor, PCBWay, it's actually not a problem. PCBWay's machining services can help you turn your CAD designs into reality using a huge range of materials and processes. For example, I can upload the step files for my top and bottom plates to be machined from polycarbonate or any other material. And I can even get a custom blade made using tough steels like 4140, which I definitely couldn't work with in my meager setup. And of course, PCBWay offers a huge range of PCB fabrication services, including their incredibly cool Flex PCB service, which lets you create circuit boards which can bend and flex during use, or you can even combine them with rigid and flexible elements in the same board, which opens up a huge range of possibilities for your creative projects. To help kickstart your combat robot build or anything cool you might be making, PCBWay has provided me with a handful of discount coupons. Simply use the code PCBWay-MakersMuse10 to get $10 off any order of $30 or more. But be quick because these coupons tend to run out pretty fast. As always, you can find more information in the description below, and big thanks to PCBWay for sponsoring this video and once again helping me bring you more content on this awesome hobby. So, the robot is done, it just needs a name. Measured response. Perfect. The first tests were promising, but it revealed a couple of shortcomings. For a start, the wheels are very low traction. That's fine, I can fix that in future. But unfortunately, the super cheap drive motors I chose struggle to even move them sometimes, and they even bog down when trying to spin on the spot. It turns out that the torque output of N20 gear motors varies wildly, and these budget ones are so incredibly gutless. They do work, but just look at the stall current difference between these ones and its equivalent that was purchased from BotBits. Yeah, one of them has way more power. So if you want a robot that can push back, definitely keep this in mind. Go with a higher reduction, which means slower speed but more torque, or just go with a more powerful motor from a reputable brand. But it does work, and even with a 3mm top and bottom plates, it's well within the weight limit. So it's time to pack it up, along with a slightly upgraded Dead Cat Bounce, and head to Robot Royale, which is Australia's fastest growing combat robot event, hosted at the University of New South Wales. This event had almost 50 robots registered to compete across two categories, the 150-gram open ant weight class and the rapidly growing 150-gram plastic ant or plant class. And even though these robots are made out of like PLA and ABS, it's brutal. Some of the most destructive robots in the country currently compete in this competition, including DES, built by James of Broken Link Robotics. This nasty vertical spinner kicks my butt on the regular. But in this case, the first match for my new budget build was an equally budget built robot, Squish and Spin, built by Ari from Ember Robotics. Instead of a ruler though, Squish and Spin has a CNC cut steel undercutting blade, which is really heavy and hits super hard. So we have thin and sharp versus chunky and heavy. Let's roll.
2, 1, begin.
Really bad sounds coming out of my mouth.
Oh well. It's always a risk of running sharp weapons in this arena because historically they do tend to get stuck in the sidewalls, but also they cut through TPU really well, so it's a bit of a trade-off. I just didn't expect it to get so stuck with that ricochet and rebound. And unfortunately with those low torque gear motors, there was really no chance of escape once it happened. In fact, when I tried to pull the robot away, it pulled the whole side of the arena with it. I had to really pull on it to get it free. I did get a few good licks on Squish and Spin, and he got a few hits on me, but overall, no real damage. But that's okay. The machine should be working fine for my next opponent, Dead Cat Bounce. Yeah, Dead Cat Bounce. My robot. It's always a risk if you run multiple robots in the same class that sometimes you'll be drawn against yourself. Now, our competition does allow you to forfeit one of your bots when this occurs because some people use the same transmitters or they don't want to destroy their own robot. But I didn't wake up at 5 AM to drive to a random university on a Sunday to not fight. So I threw the remote for measured response to James and I took control of Dead Cat Bounce. Let the bloodbath begin.
Catch me.
Get in. Hit in 30 seconds. Hit opens in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
I win, but also I lose. Measured response is cooked. But to give James some credit, Measured Response began to experience some really weird weapon ESC control issues in this fight, where the motor's ESC was arming and resetting constantly randomly at different throttle levels, so he didn't really have any weapon control during that entire fight. I still have no idea what caused this, but it did render the robot effectively defenseless, and then after a few roofings where Dead Cat Bounce hit the weapon blade directly, the motor was completely cooked anyway. In a desperate attempt to get it working, I replaced the motor with a different config I threw together the night before, expecting this to happen, and I resoldered all the wires, but I probably should have replaced the speed controller, because despite it working totally fine on the test bench, it was still really dodgy in its third and final fight against a hammer saw robot called Hex Switch. Here's how that fight went.
Smaller target.
I've only got 2 wheels touching the ground, so I'm basically a 2-wheel.
So is he. It's even that.
Thanks, James.
30 seconds to the pit. Pit opens in 3, 2, 1. Don't want to touch this, guys.
Finish it! Oh, I saw small! I saw small!
I managed to get the weapon to work for some of that fight, but it couldn't do very much, and let's just say controllable wasn't really part of my strategy, so into the pit I went. And with that, Measured Response is out of the competition, but I'm not really going to complain because considering how cheap this was to build, it has a lot of potential. So yeah, you can absolutely build a combat robot on a budget, but I would definitely do some things a little bit differently. Instead of trying to buy random AliExpress N20s, I would go with a slightly more expensive pair from a reputable parts supplier because these are likely to have far more torque and move the machine a lot more efficiently. And this weapon motor, as you saw in the fight, was completely messed up after Dead Cat Bounce had its way with it. But I've had fantastic success with these smaller motors which couple through a 5mm bearing to absorb impacts. In fact, that's what I used on Death Ray, and it went up against DES for 3 whole minutes, and the weapon motor did not break. And for weapon ESCs, that BL Heli S has been reliable for a very long time, so I think it's just finally died. Maybe a tiny component got damaged. I would still go with them for weapon control, although if you like, you could go with the newer AM32 ESCs, which is the one that I use on Dead Cat Bounce. It offers a little bit more control at lower speeds, especially if you're going to go back, forward, and reverse a lot with higher torque at low speeds. But really, there's not a huge difference for weapon motors. And finally, the EVA foam wheels technically worked. I didn't actually lose any drive motors, but the traction, as you saw, was terrible. So you'd probably be better off with a 3D printed hub and O-ring tires, or honestly, just buy low-cost ready-made wheels when you buy the N20 gear motors, and then you've got a proven working platform to get your first robot off the ground. And for proof this recipe can work, just check out Squish and Spin, which was built by Ari of Amber Robotics. It's a very new team, and this was his first open class ant weight. It has the same basic components as my robot Measured Response, but it's wrapped in a TPU chassis, and instead of a ruler, it has a large hardened steel undercutting blade directly bolted to an incredibly cheap Outrunner from AliExpress. If you used PCBWay to make a similar blade, you could get something like Squish and Spin up and running without much trouble at all and on a very small budget. And despite some initial weapon and driving teething issues, Squish and Spin did very well in its competition and went on to place 3rd overall after handedly annihilating Dead Cat Bounce. Dead Cat Bounce is well overdue for a complete overhaul, and by this point of the competition, it could barely drive, but the weapon was still dangerous as ever, and Squish and Spin just tanked it, tearing right through the front armor and cracking all the magnets in the hub motor. It was seriously impressive. I want you to get out there and build something. So if tiny combat robots sounds like your kind of thing, then I'll be keeping an up-to-date parts list on my website. And if you want custom parts made, then PCBWay is the place to go. Take advantage of that coupon to get $10 off orders of $30 or more. And I'll see you again very soon. Catch you later, guys. Bye.